Hey there and welcome. I'm really glad you're here. Today we're going to dig into one of the most important building blocks in Amazon Web Services networking, the Internet Gateway, or IGW for short. Now, if you've ever spun up a server in the cloud and wondered why on earth it couldn't reach the internet, or why the whole world could suddenly reach it, this is the piece that explains it. Think of the Internet Gateway as the main door between your private cloud network and the public internet. By the end of this video, you'll understand exactly what it is, why you need it, how it actually moves traffic in and out, and when you should use it versus when you absolutely should not. We'll go step by step with real examples, so don't worry if you're brand new to this. Let's open that door together. So let's start with the basic definition. An Internet Gateway is a managed VPC component that connects the resources inside your VPC to the public internet. Let's unpack those words. A VPC, or Virtual Private Cloud, is your own private, walled-off network inside AWS, your own little slice of the cloud where your servers and databases live. By default, that network is sealed off from the outside world, which is great for security but useless if you actually want people to visit your website. The word managed is key here. You don't rack a physical router, you don't patch it, you don't worry about it crashing or running out of capacity. AWS runs it for you, it scales automatically, and it's highly available across the whole region. You just attach it, and it works. So in one sentence, the IGW is the official AWS-managed bridge that lets your private network talk to the wider internet. Here's the picture to hold in your head. On the left, you have your VPC, your private network. On the far right, you have the internet, everything out there, every user, every browser, every API. And sitting right in the middle is the Internet Gateway, acting as the connection point between the two. The crucial thing to notice is that this is a two-way street. The IGW handles outbound traffic, like your server reaching out to download an update, and it handles inbound traffic, like a customer's browser requesting your web page. Traffic flows both directions through that same managed gateway. So picture it like the main entrance to an office building. Deliveries go out, visitors come in, and everyone passes through that one controlled doorway. That two-way nature is what makes the IGW different from some other AWS networking pieces we'll meet later. Now, why do we even need this thing? Let's say you've launched an EC2 instance. That's just a virtual server in AWS, and you've given it a public IP address so it can be found on the internet. With an Internet Gateway attached to your VPC, that server becomes reachable both ways. Someone typing your web address into their browser can reach your server inbound, and your server can reach back out to the internet for things like software updates or calling external services. The IGW is what completes that path. Imagine you've built a little online store. A shopper on their phone in another city sends a request, it travels across the internet, arrives at your IGW, and gets routed to your EC2 instance, which sends the web page back out the same way. That whole round trip is only possible because the gateway is there to carry traffic across the boundary. But here's the part that trips up almost every beginner, and it's a really common misconception, so pay close attention. What happens without an Internet Gateway? You take that exact same EC2 instance, you even give it a public IP address, but there's no IGW attached to the VPC. The result, it's completely unreachable. There's literally no path to the internet at all. And this is the misconception I want to flag. People assume that a public IP address by itself means a server is on the internet. It does not. A public IP is just a label, an address. It's like having a street address printed on your house, but with no road actually connecting your street to the rest of the city. The address exists, but no traffic can get there. Without the gateway, that public IP is meaningless. The IGW is the road. Remember that, because it explains a huge number of real-world headaches where people swear their server should be reachable, and it just isn't. So how does it actually work under the hood? Let's trace a real flow. Say you have a public EC2 instance with the address 54.2.34.56. When that instance wants to send traffic out to the internet, the packets travel to the Internet Gateway, and the gateway pushes them out to the wider internet. When a response comes back, it returns through that same gateway and finds its way to your instance. The IGW is quite literally the single entry and exit point for your entire VPC's internet traffic. Everything coming in and everything going out of that VPC, bound for the public internet, passes through this one logical gateway. And because AWS manages it, there's no bottleneck you need to size or babysit. It scales horizontally and is redundant by design, so it doesn't become a single point of failure, even though it's a single point of passage. Now, just attaching an internet gateway is not enough to make a server reachable from the outside. For inbound access, you actually need three things lined up together, and if any one of them is missing, it won't work. First, your resource needs a public IP address or an elastic IP. That's its findable address on the internet. Second, your route table needs a route that says 0.0.0.0/0 points to the IGW. That's the rule that sends internet-bound traffic to the gateway, and we'll look at that closely in a moment. And third, you need a security group that actually allows the incoming traffic, because security groups act as a firewall around your instance, and they block everything by default. Think of it like getting into a concert. You need a ticket with a seat number. That's your public IP. You need the road and signs directing you to the venue. That's the route to the IGW. And you need the bouncer at the door to let you in. That's the security group. Miss anyone, and you're not getting in. Here's an important detail about where the IGW actually lives. The Internet Gateway is attached to the VPC itself, not to any single subnet. A subnet is just a smaller subdivision inside your VPC, a segment of your network. You might have several subnets in one VPC, but you only attach one Internet Gateway to the whole VPC, and it serves the entire VPC. So you don't create a gateway per subnet. Picture an apartment building. The VPC is the whole building, the subnets are the individual floors, and the IGW is the single main entrance at street level that the entire building shares. Every floor that's allowed to use that entrance goes through the same front door. This matters because it leads straight to the next question. If the gateway serves the whole VPC, then what decides which subnets actually get to use it? And that's exactly the right question. Who actually uses the IGW? Even though the gateway is attached to the whole VPC, not every subnet gets to use it. This is where the famous distinction between public and private subnets comes from. A public subnet is one that uses the IGW, and it does so through its route table, the set of traffic rules attached to that subnet. A private subnet does not use the Internet Gateway directly. Here's the big idea that surprises a lot of people. A subnet isn't born public or private. There's no checkbox that magically labels it. What makes a subnet public or private is entirely determined by its routing rules, whether or not its route table has a path to the Internet Gateway. So the gateway is available to the whole building, but each floor's own rulebook decides whether it walks through that front door or not. Let's look at the rulebook itself, because this is the single most important concept in the whole topic. Here is a public subnet's route table. A route table is just a list of destinations and where to send traffic for each one. The first row says, traffic destined for 10.0.0.0.16 goes to local. That just means traffic staying inside your own VPC stays inside, handled internally. But look at the second row. Destination 0.0.0.0, target Internet Gateway. That .0.0 is shorthand for everything, every possible address on the internet. It's the catch-all default route. So this row says in plain English, anything not inside my own network, send it to the Internet Gateway. That one line, 0.0.0 pointing to the IGW, is precisely what makes a subnet public. If you remember one thing from this entire video, make it this. That route is the definition of a public subnet. Now compare that to a private subnet's route table, and the difference jumps right out. Again, the first row is the same. 10.0.0.0/16 goes to local, so internal VPC traffic works fine. But look at the second row now. Destination 0.0.0/0 points to a NAT gateway, not to the Internet Gateway. There is no route to the IGW anywhere in this table. And because there's no path to the gateway, this subnet is not public. It can still reach out for things like software updates through that NAT gateway, which we'll explain shortly, but the outside internet has no way in. So notice how the only real difference between public and private comes down to one line in a routing table. Same VPC, same gateway sitting there available, but one subnet has the route and the other doesn't. That's the whole secret. I keep mentioning the NAT gateway, so let's compare the two side by side because mixing them up is one of the most common mistakes people make. First, the Internet gateway. Where is it used? In public subnets. What direction does it work? Two-way. It handles both inbound and outbound traffic. Does the resource need a public IP? Yes. The instance behind it must have its own public or elastic IP to be reachable. And what is it best for? Public-facing things like a web server or a load balancer, anything the outside world needs to connect to directly. Keep this card in mind as we look at its counterpart, because the contrast is where the understanding really clicks. Now here's the NAT gateway for comparison. Where is it used? In private subnets. What direction does it work? One way, outbound only. This is the heart of it. A NAT gateway lets your private servers reach out to the internet, but it does not let the internet initiate a connection back in. The public IP lives on the NAT gateway itself, as an elastic IP, not on your individual servers, so your private instances stay hidden behind it. And it's best for things like private application servers that need to download updates or call an external API, but should never be directly reachable from outside. So think of the Internet gateway as a two-way front door for public servers, and the NAT gateway as a one-way exit that lets your private servers step out to run errands but never lets strangers walk back in. Same goal of Internet access, very different security posture. So with both of those tools in your kit, how do you decide which one to reach for? It all comes down to a single, simple question you should ask yourself about every resource you deploy. Does this thing need to be reachable from the internet? That's it. That one question drives the entire decision. Don't overthink it. For each server, each database, each component in your architecture, just ask, does the outside world need to start a connection to this? Hold that question in mind because the next two slides give you the yes answer and the no answer, and together they cover basically every situation you'll run into. If the answer is yes, this resource needs to be reachable from the internet, then you make it public and you use an internet gateway. What kinds of things fall into this bucket? A public web server that's serving your website directly to visitors. A load balancer, like an application load balancer, that accepts incoming traffic and spreads it across your servers. Or a bastion host, which is a hardened jump server you SSH into to securely reach the rest of your private network. All three of these have something in common. Someone or something on the internet needs to initiate a connection to them. The visitor's browser reaches the web server, the user's request hits the load balancer, the administrator connects to the bastion. Anything that has to accept that first knock on the door from outside belongs in a public subnet behind an internet gateway. But if the answer is no, this resource does not need to be reachable from the internet, then you keep it private and you do not use the IGW directly. Take an application server that runs your business logic. It needs to fetch updates and maybe call an external API, so it goes out through a NAT gateway, but nobody from the outside should be able to reach it directly. Then take a database. It should have no internet access at all. It only ever talks to your app servers inside the VPC. Same with a cache or any internal service. No internet path needed. And here's the why behind all this. It's about shrinking your attack surface. Every resource you expose to the internet is one more door an attacker can rattle. So the golden rule is, expose only what truly must be exposed and keep everything else locked away in private subnets. Your database holding customer data should be the most isolated thing you own. Let's tie it all together with a real-world example you'll see constantly in the wild, the classic three-tier web application. Picture the flow. Users out on the internet send their requests in through the internet gateway. The first thing they hit is a load balancer, which sits in a public subnet. It's public precisely because it's reachable via the IGW. The load balancer then forwards traffic inward to your app EC2 servers, which live in a private subnet. And those app servers talk to a database, which sits in an even more protected private subnet. Notice the beautiful layering here. Only the load balancer is exposed to the internet, while the application logic and the database stay completely private, shielded behind it. A user can reach your front door, but they can never directly touch your app servers or your database. That's not an accident. It's a deliberate, secure design, and the Internet Gateway is what makes that one public entry point possible. But there's a loose end in that design. Those private app servers still need to reach the internet sometimes, to download security patches, install updates, or call an outside payment API. So how do they get out without becoming exposed? This is where the NAT Gateway earns its keep. The app server sends its outbound traffic to a NAT Gateway. The NAT Gateway forwards it through the Internet Gateway to the internet, and the responses come back along the same path. The key point is that this is outbound only. The private apps can reach out, but nothing on the internet can reach into them. And the database, it stays completely isolated, with no internet path at all, not even through NAT. So you get the best of both worlds. Your private servers stay patched and functional while remaining invisible and unreachable from the outside. That combination of IGW for public traffic and NAT for private outbound is the backbone of nearly every well-designed AWS network. All right, let's pull together what we've learned, because a few key ideas really deserve to stick. First, the Internet Gateway is what connects your VPC to the internet. It's the bridge across that boundary. Second, it supports both inbound and outbound traffic. It's a genuine two-way connection, unlike the one-way NAT gateway. And third, remember that it's attached to the VPC as a whole, not to any individual subnet. There's one gateway serving your entire private cloud, like the single main entrance to the whole building. Hold on to these three, because they're the foundation everything else rests on. And here's the second half of the recap, the practical rules you'll actually apply. To make a subnet public, its route table needs that route, 0.0.000, pointing to the IGW. That one line is the magic that defines a public subnet. Any public resource also needs its own public or elastic IP address, because remember, a public IP without a gateway is useless, and a gateway without a public IP can't deliver inbound traffic either. You need both. And finally, private resources like your databases and internal services should not use the IGW directly. Keep them tucked safely behind NAT or fully isolated. The big takeaway in one sentence: the Internet Gateway is the main internet door for your public resources, and good architecture means being very deliberate about who you let walk through it. And that's a wrap. You now understand what an Internet Gateway really is, the main door between your VPC and the internet, why a public IP alone is never enough without it, how routing decides which subnets get to use it, and when to choose an IGW versus a NAT gateway to keep your architecture both functional and secure. That's the kind of foundational knowledge that makes the rest of AWS networking suddenly make sense. Thank you so much for watching and for sticking with me all the way through. If this helped things click, please give it a like, share it with someone who's learning the cloud, and subscribe for more AWS and cloud videos. Until next time, keep building, and I'll see you in the next one.